Two satellites, hurtling through space at 28,000 kilometers per hour, just exchanged 14.4 terabytes of data in under 7 minutes, using nothing but laser beams. China's private firm Starcom has smashed records with a jaw-dropping 400 gigabits per second Intersatellite link, 4 times faster than Starlink's current system. This isn't just a tech flex, it's a major move in the global race to control the future of space-based internet. Here's how China just changed the rules of orbital communication. Starcom, a commercial Chinese aerospace startup founded in 2020, has accomplished what no other company or country has publicly demonstrated before. A laser communication test between two satellites with a staggering throughput of 400 gigabits per second Gbps. That's 4 times faster than the laser crosslinks currently deployed on SpaceX's Starlink satellites. The test involved 2 satellites, Guangchuan 01 and Guangchuan 02, launched into low Earth orbit (LEO). In November 2023 aboard a Zhuque 2 rocket developed by the private company Landspace. These satellites were placed 640 kilometers apart in orbit. Then, on March 18, 2024, the pair successfully established a high-speed optical communication link and maintained it long enough to transfer 14.4 terabytes of business data in just 6 minutes and 44 seconds. That data rate might sound simple at first glance, but it's mind-bending in the context of space. Laser links in orbit demand extreme precision. Unlike fiber optics on Earth, where the light beam is contained in a cable, lasers in space must stay perfectly aligned between 2 fast-moving spacecraft. And that's exactly what Starcom achieved, with tracking errors of less than 5 microradians, or just 0.0002.865 degrees. That level of stability is unheard of in commercial satellite tech. So, how fast were the satellites moving? Around 7.8 kilometers per second, or 28,000 kilometers per hour. And yet their laser beams remained locked, thanks to ultra-precise steerable telescopes on board. The 400 gigabits per second rate itself includes not just raw payload data, but also protocol overhead, service signals, and error correction systems. A reminder that communication in space is as much about stability and reliability as it is about speed. Even so, net throughput still exceeded 290 gigabits per second, which remains higher than any previous public laser crosslink demonstration globally. This breakthrough marks more than just a new technical record. It signals a fundamental shift in the global satellite internet landscape. With this test, China has shown it's no longer playing catch-up in the orbital communications race, it's taking the lead. The implications go far beyond numbers on a data sheet. Today's satellite constellations, like SpaceX's Starlink, Europe's planned Iris Superscript 2, and China's own upcoming Guoang and Qianfan, are all pursuing the same core objective: global broadband coverage through vast swarms of low Earth orbit satellites. But here's the catch. No matter how many satellites you have, they're only as powerful as their ability to talk to each other. Traditional satellites often rely on ground stations to transfer data between orbits or back to Earth. That creates bottlenecks, latency, and geopolitical vulnerabilities. Enter laser crosslinks, a game-changing alternative that allows satellites to communicate directly, bypassing ground infrastructure entirely. It's faster, more secure, and more efficient. That's where Starcom's test matters most. By successfully demonstrating 400 gigabits per second between satellites, they've unlocked the potential for a truly seamless orbital network, a space internet, that doesn't need to wait for a ground station to come into view. This matters for civilian connectivity, sure, but it's also a military and strategic asset. With secure, high-speed orbital data links, China could establish independent and encrypted global communication systems, immune to many forms of surveillance or disruption. Compare that to Starlink's current system. As of now, Starlink satellites employ optical interlinks rated around 100 gigabits per second. Europe's Hydron project, still in development, aims for 100-plus Gbps shortly. MIT's T-Bird mission demonstrated 200 gigabits per second from space to ground in 2023. All impressive, but still trailing the speed China has now demonstrated in orbit. Even more striking is the fact that this capability came from a private company, not a government agency. China's shift toward commercial space is accelerating. Just like the US empowered SpaceX and Rocket Lab, China is now enabling companies like Landspace, iSpace, and Laser Starcom to innovate with agility and take pressure off state-run programs. Now that China has pulled off the fastest satellite laser link ever recorded, the big question is, how will this scale? Laser Starcom has hinted at the answer. According to its official materials, the company's optical communication terminals are modular and scalable, capable of operating at 10 gigabits per second, 100 gigabits per second, and 400 gigabits per second, depending on the mission's needs. This adaptability means that different satellites in a constellation can be outfitted with terminals optimized for their roles, some prioritizing raw data volume, others energy efficiency or latency. But laser communication is useful far beyond megaconstellations. Consider Earth observation satellites. These missions collect enormous volumes of data, weather patterns, high-resolution imaging, environmental scans, but they often have just minutes per orbit to downlink their payload to ground stations. That's a massive limitation. With orbital laser crosslinks, satellites can now offload that data to companion satellites in better positions or with direct lines of sight to Earth, no waiting for the next pass over a ground station. Science missions could also benefit tremendously. High-bandwidth instruments, like those used for climate monitoring, deep space imaging, or even particle detection, produce huge volumes of data that need to be transmitted back quickly and intact. In fact, NASA's Lunar Laser Communication Demonstration, LLCD, back in 2013 laid the foundation for this kind of thinking, showing how high-speed lasers can connect the Moon to Earth. And it doesn't stop at Earth. China is heavily invested in building a permanent lunar research station in the 2030s. For that to function as more than just a symbolic outpost, it will need robust, high-throughput communication. Laser links could connect lunar orbiters with surface assets and relay satellites, ultimately beaming petabytes of science data back to Earth in real time. Still, challenges remain. Scaling up laser networks will require advanced beam steering, thermal management, and adaptive optics to handle environmental variability, especially for space-to-ground links, where atmospheric interference can distort or scatter the beam. But Laser Starcom's achievement shows that these challenges are being tackled head-on. And with private sector momentum accelerating, China now has a blueprint to mass deploy these capabilities across both commercial and state-run constellations. In just 7 minutes, 2 satellites beamed more data across space than most home internet users consume in a year. But behind those numbers lies a larger truth. China's commercial space sector is no longer a quiet observer. With Laser Starcom's record-breaking 400 gigabits per second link, China has catapulted itself to the forefront of orbital communications. This isn't just a speed record, it's a statement of intent. As the world builds the next generation of internet in the sky, one thing is clear: the battle won't be fought on the ground. It'll be fought in beams of light, streaking silently across space. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries, and don't forget to leave a comment below. Also, you can visit our website, spaceinews.com. Thank you for watching, and see you next time.